The perplexing questions about Saturn intertwine like the concentric rings of this giant planet. Does Saturn have a solid surface? Or are its clouds so dense that they are extremely compact, possibly forming strange forms of matter, such as Hiroki metal? Is there rock on this planet? Why are the rings so brilliantly bright? How long have they existed? What lies beneath the thick orange clouds of Titan, Saturn's largest moon? What is the connection between Moonfish and Saturn's rings? This giant planet will reveal to us the mysteries of the solar system's evolution as well as the origins of life. At a distance of approximately 1.5 billion kilometers from the Sun, Saturn completes one orbit in 29.5 Earth years. Over the past 5 years, the world's population has increased by approximately 2.5 billion people. The average life expectancy has risen from 64 to nearly 72 years. The internet has experienced explosive growth and now has around 4 billion users, equivalent to half of the global population being online. Saturn is the Roman name for Kronos, the god of time in Greek mythology, who, out of jealousy, devoured the children he had fathered. In mythology as well as in the ever-changing universe, time is the destroyer of all things. To explore Saturn, mission planners launched the Cassini spacecraft to conduct a series of flybys of the planet. Each time, the spacecraft uses the planet's gravity to accelerate on its journey. In 1979, Pioneer 11 flew past Saturn, followed by Voyager 1 in 1980 and Voyager 2 in 1981. Cassini will be the first spacecraft to enter Saturn's orbit. On the evening of October 15, 1997, the mighty Titan 4B rocket launched from Pad 40 at Kennedy Space Center. The Cassini spacecraft was the result of 2 decades of close collaboration between NASA and the European Space Agency, with significant contributions from the Italian Space Agency. At this moment, some people on Earth have spoken out in protest. They feared that if the launch failed, the nuclear power generator aboard the Cassini spacecraft would release 8 kilograms of radioactive plutonium. After 7 years of daring adventure through the dark expanse of space, the spacecraft was finally captured by Saturn's gravity on June 30, 2004. But Cassini's primary mission lasted only 4 years, yet it continued operating resiliently far beyond its expected lifespan. The Cassini mission was extended twice, the first time by an additional 2 years at the equinox, and the second time by another 7 years at the solstice. However, Cassini's entire exploration journey will take place in less than half a year on Saturn. From late winter to early summer, the Saturn system is about 9.5 astronomical units from the Sun, nearly 10 times farther than Earth's distance from the Sun. This colossal clockwork machine operates at a speed of up to 34,821 kilometers per hour, 10 times faster than the velocity of a bullet fired from a rifle. This planet spins extremely fast, taking only 10 hours and 39 minutes to complete one full rotation on its axis. Therefore, while 1 year on Saturn is equivalent to just 11 Earth days, it amounts to about 24,500 days based on the planet's own timekeeping. Saturn, primarily composed of hydrogen and helium, is the least dense planet in the solar system. It's often said that if you had a bathtub big enough, Saturn would float on water. But this isn't. But its density is lower than that of liquid water in Earth's oceans, despite its enormous size. You could fit 764 Earths inside Saturn's volume. The first mission to explore Saturn was officially named Cassini-Huygens, after 2 brilliant 17th-century scientists. Giovanni Domenico Cassini, an Italian-born French astronomer, and Christian Huygens, a Dutch scientist. The key figures in the scientific revolution both collaborated and competed with each other throughout their careers. During this process, the study of birds evolved and transformed into astrophysics. As the director of the Paris Observatory, Cassini built and upgraded long-refracting telescopes. But Huygens found a way to eliminate that complex tube, inventing a telescope that required no tube and improving the eyepiece for better quality. In 1665, Cassini also discovered the Great Red Spot on Jupiter and used it to measure the rotation period of the giant planet. Huygens built upon Galileo's idea to invent the pendulum clock and successfully developed the balance spring watch. Both are significant advancements in space research. Cassini mapped the markings on Mars' surface, although Huygens was actually the first to observe them. And Huygens calculated that a day on Mars lasts 24 hours and 30 minutes, differing by only 7 minutes from the currently accepted accurate figure. By collecting parallax observations of Mars, Cassini became the first person to estimate the size of the solar system. Cassini applied the timing method proposed by Galileo, based on observing the eclipses of Jupiter's moons, to determine the lines of longitude on Earth. While researching to refine the optical geometry of lenses, Huygens laid the theoretical foundation for the wave theory of light, paving the way for the later emergence of quantum mechanics. Cassini explained the phenomenon known as zodiacal light, which astronomers consider to be the result of sunlight reflecting off dust within the solar system's plane. In his later years, Huygens asserted that liquid water was the key factor in the search for extraterrestrial life. We have known Saturn as the ringed planet since 1655, when Christian Huygens explained the phenomenon that Galileo had observed 45 years earlier. Moons, Since most lunar craters move within the plane of the ring, you can only observe them at the edge. From the right side, you can see the tiny Prometheus, spanning just 86 kilometers in width, as it traverses a vast stormy region measuring 1,062 kilometers. Little Pandora gently moved from left to right. Here, Mimas, of average size, moves along the wire at 14 kilometers per hour, passing in front of Rohe, which is larger but only travels at 8 kilometers per hour on the wire. When the Cassini spacecraft was launched, scientists had confirmed 18 moons orbiting Saturn, while suspecting the existence of 13 others. When the Cassini mission ended, astronomers had confirmed 53 moons, along with 9 others marked as potentially habitable. Among them, only one celestial body is truly colossal. That is none other than Titan. In 1655, astronomer Christian Huygens became the first person to observe Titan. In 1671, Cassini observed Iapetus, then Rhea in 1672, and in 1684, he discovered both Dione and Tethys simultaneously. In 1789, the siblings William and Caroline Herschel discovered the moons Mimas and Enceladus. In 1848, Hybron was discovered simultaneously by 2 research teams, the father-son duo Quilliam and Tyrone in the United States, and scientist William Herschel in England. Frost was the first lunar rill discovered through photography, identified by American astronomer William Henry Pickering in 1898. Moons may be objects captured by the planet's spin, each of Saturn. Before Cassini, no one thought Enceladus was anything other than a frigid, lifeless ball of ice. But the scientific research process has revealed an astonishing discovery. Enceladus has a diameter of approximately 482 kilometers. The first close-up image of it was captured by the Voyager 2 spacecraft in 1981, revealing an extremely bright surface with almost no traces of impact craters. In fact, Enceladus is the brightest celestial body in the solar system, and the first clue to a more complex story was revealed by data from the Cassini spacecraft. The natural feature of the lunar pulse resembles a comet more. The tiger stripes curve around Enceladus' south pole. A sword flying near the far south has revealed a shocking secret. The infrared spectrometer on the Cassini spacecraft detected that this region is about 100 degrees hotter than other areas of the moon's fissure. And this temperature pattern directly corresponds to the 4 prominent tiger stripes visible on the southern terrain of the Trong Son mountain range. It turns out, those were cracks and water channels on the surface of the ice layer. Each one is about 150 kilometers long and roughly 1 kilometer wide. The scientists named them Alexandria, Cairo, Bada'a, and Damarcus. From each drop of water, tiny water droplets and ice crystals scatter into the air. Finally, the Cassini spacecraft located more than 100 geysers like this. The mission planners scheduled an increase in flyby flights for October 2015. Moving within a 50 kilometers range from Enceladus' south pole and through the counter-streaming particle plumes enables the instrument to analyze their composition and properties. Mostly rock. Additionally, there is a small amount of ammonia, methane, and carbon dioxide, essential compounds related to life. If present, bacteria could use hydrogen gas as an energy source. Some grains taste as salty as frozen seawater, rich with the flavors of sodium and potassium. The research team hypothesizes that beneath the icy crust, there could be a vast subsurface ocean. As it moves around, carbon dioxide creates a bubbling effect, similar to carbonated soda in a bottle. When they found an escape to relieve the pressure, bursting through the cracks like tiger stripes, they erupted into the space, like champagne foam spraying wildly when the cork pops. Most of these salty ice particles fall onto the moon's surface as snow, helping to decorate and reshape the landscape of Enceladus. Weak gravity, making the moon appear as if the moon stopped shining, Saturn's E-ring would completely disappear within just a few hundred years. Tracking and simulating the ice ridges formed by interaction with water droplets allows researchers to perform calculations. The mass of Enceladus is being drawn into Saturn's rings. The orbit of Enceladus resonates with that of Titan. This phenomenon is believed to be the cause of heating the rocky cores of both moons. Taiwan may also have a hidden ocean beneath its surface. The largest impact crater on the moon is Girasol, with rays extending at least 500 kilometers from the surface, helping scientists determine its geological age. The younger impact craters than Grisha disrupt the light rays, while the older ones lie beneath them. The water is heated by these moons, then evaporates and escapes through cracks in the seafloor. We know this because the Cassini spacecraft detected tiny silica particles, the kind that can only form in boiling water. On Earth, hydrothermal vents on the ocean floor are true oases of life. The hot water surged upward, carrying abundant energy while swirling nutrient particles in the current. Could a similar phenomenon be occurring beneath the icy crusts of Saturn's snow-covered moons? To investigate further, future missions must search for amino acids, fatty acids, and long-chain hydrocarbon molecules. And perhaps even microorganisms clinging to ice crystals swept far from the abyssal depths of the ocean floor. Many astrobiologists are drawn to Titan because, despite its extremely low temperatures of around -180 degrees Celsius, it has high humidity. If any form of life exists on or beneath Titan's surface, it is almost certainly unrelated to life on Earth. Titan has a diameter and mass comparable to Mercury. The surface gravity of Titan is nearly equivalent to that of Earth's moon, but differs from Mercury or other satellites. Titan has a dense atmosphere, even thicker than Earth's, but the reason behind this phenomenon remains a mystery to scientists. This is the second largest moon in the solar system. With a diameter of 5,150 kilometers, it is only smaller than Jupiter's Renmet. Titan is significantly larger than Saturn's other moons. One hypothesis suggests it was formed from the collision of multiple moons within the same system. When the mission ends, the Cassini spacecraft will have flown past Titan 127 times. Each time it takes off, the spacecraft must endure an additional gravitational force equivalent to nearly 1,000 kilograms of extra fuel. When the two Voyager spacecraft flew by in 1980 and 1981, they observed only an orange planet shrouded in a thick haze. American and European scientists were so intrigued that they began outlining ideas for what would later become the Cassini-Huygens mission. After 23 years, an international research team launched the Huygens probe to land on Titan's surface. On January 14, 2005, the European-made Huygens probe plunged into the atmosphere of Saturn's moon Titan using its heat shield. The parachute deployed and hovered for over 2.5 hours in the nitrogen-rich atmosphere. Images from the camera captured an eerie scene. Huygens landed smoothly on a frozen methane beach by Lake Hirakaban. Huygens continued transmitting data for another half-hour after landing, sending back images that showed rounded pebbles likely formed from solid ice. On Titan, methane exists in liquid form and plays a role similar to water on Earth. On Titan, methane can exist simultaneously in all three states: solid, liquid, and gas under the moon's temperature conditions. It is entirely possible that a life form could exist and thrive on this moon, sustained by the endless Hirakaban rice rains. A second genesis entirely separate from life on our Earth. Since the Voyager spacecraft first observed Titan, scientists have hypothesized that the surface of this moon could be covered by liquid oceans. But the long orange mist had obscured the truth. This fog layer forms when ultraviolet rays from the sun break down methane in the upper atmosphere. The molecules bond together to form long chains, growing large enough to fall from the sky. The methane byproducts form floating snow layers, creating a vast network of dunes encircling Titan's equator. Cassini's camera was equipped with a near-infrared filter, allowing it to peer through the orange haze to confirm the existence of liquid regions. The footage shows areas that are surprisingly quite flat. Are they truly oceans? Or just methane puddles? Or perhaps asphalt seas? This result was provided by the visible and infrared mapping spectrometer on the Cassini spacecraft. The mirror reflection phenomenon begins to occur when a bright beam of sunlight shines onto the transparent surface of the liquid and reflects back. With the Cassini spacecraft's radar system, flat surfaces like lakes and seas appear pitch black, unless waves disturb the water. Titan truly has oceans and lakes containing a mixture of liquid hydrocarbons such as ethane, methane, and propane. It's strange, they mainly form in the area near the North Polar region of Titan. The elliptical, eccentric orbit of Saturn is the cause of this phenomenon. The northern hemisphere of Saturn is warmer in summer than the southern hemisphere. This is because Titan's tilt makes summers in the southern hemisphere more extreme. As a result, all the liquid methane in the southern region evaporated, condensed, and fell as rain in the northern area. Gradually, the entire system was completely reversed. In 15,000 years, all the lakes on Saturn's moon Titan will be located in the southern hemisphere. This is called Legimi, which is larger in size than Lake Superior on Earth. Its depth can reach up to 150 meters. The strange foam islands suddenly surfaced, spewing white froth from deep beneath the water. Titan has hydrocarbon reserves 10 times greater than Earth's total oil and natural gas reserves. Stretching 300 kilometers across Titan's southern pole, a massive, toxic, and frozen Hiroshima cloud swirls ominously. This vortex appears to form as Titan's southern hemisphere enters autumn. Titan is releasing methane into space at an astonishing rate. The atmosphere cannot be sustained for more than 20 million years. Something needs to be added here. But what exactly? Cassini's radar provided the answer. These mountains rise several kilometers high and are most likely ice volcanoes. Some may be active, spewing methane from deep within the moon's interior. Its entire surface is deformed by Saturn. This makes the inside warm enough to melt the ice layer. Unlike the subsurface ocean on Enceladus, which has a rocky bottom, Titan's ocean is likely sandwiched between layers of water ice. Therefore, if an underground ocean exists, it may be isolated from the high-temperature chemical reactions at hydrothermal vents, losing all potential to sustain life. Even after the Cassini-Huygens mission, we still cannot determine Titan's age, its formation origin, or the lifespan of its unique atmosphere. Evidence suggests a catastrophic event occurred in the Saturnian system, likely around 100 million years ago, causing Titan to form from smaller objects or providing the energy to transform a primordial, frozen Titan into an active system, possibly similar to early Earth. To find the answer, we must travel back in time, pierce through the thick layers of misty clouds, glide over the hydrocarbon sea, and then cut across Titan's nitrogen sky. Years. But by 1655, using a more advanced optical system, Christian Huygens discovered a flat ring encircling a spherical planet. 20 years later, Cassini discovered it wasn't just a single ring, but multiple distinct rings separated by gaps. Later, the widest gap was named the Cassini division. According to research, it spans up to 48,000 kilometers in width and is not entirely empty. In 1859, Scottish astronomer James Gladwell demonstrated that the rings were not solid disks but instead composed of countless tiny particles. Every speck of dust, pebble, or boulder orbits the planet in its own path, fighting for space among trillions of others. Even though they all fly at speeds of several kilometers per second, they only collide with each other very gently. The concentric rings are named with letters from A to G, in the order they were discovered. Material near Saturn's clouds in this ring orbits the planet in about 4 hours, while particles farther out in the F ring take much longer, at least 4 times as long. It wasn't until the Cassini spacecraft conducted its survey that scientists realized this ring was astonishingly flat. It's hard to believe they average only 10 meters in height, from top to bottom, about the same as a 3-story building. These rings are over 30 million times wider than they are tall, and the material composing them can oscillate up and down, forming temporary folds. On the broad plane of the ring, one can observe many complex wave patterns. Each of these formations is shaped by the characteristic gravitational force resonating with Saturn's moons. Although the fundamental physics of ring systems is quite simple, primarily shaped by gravity and collisions. But the complex structure of the rings is very difficult to model mathematically, even though Cassini observed them for 13 years. The pressure from sunlight and Saturn's magnetic force can push or pull surrounding objects. The mission team executed a series of special flights through Saturn's rings, positioning Cassini between the rings and Earth. The researchers used 3 different radio wavelengths to transmit signals through the ring material, thereby creating a color-coded map that indicates particle size. The red area contains a higher concentration of large-sized particles, while the blue area primarily consists of smaller particles. Radio waves appear in the lower half of this image, revealing finer and more detailed structure compared to the visible light photograph. Most particles are small in size, ranging from tiny crystals smaller than dust grains to the size of pebbles. Ice boulders and massive rocks are less common, with sizes comparable to houses or even as large as a mountain. The moonfish is in the stage of forming or gradually fading away. Viet held a medium-sized nucleus in his hand, feeling as if he were gripping a layer of thick, icy cream, within which hid a frozen lump of ice cream. Viet packed different particles between the rings, making it nearly impossible for light to pass through ring B of the shrinking snowballs. The astronaut will have to dig a tunnel through it. The A ring has fewer obstacles, while the G ring is extremely hazy, like a drifting mist or wisp of smoke. The Cassini spacecraft confirmed that these rings are primarily composed of nearly pure water ice, but a small amount of simple organic compounds gives them color and shading. Tollens. Recently, while flying past the dark side of Saturn, the Cassini spacecraft captured vivid images revealing the intricate colors and structures of the variations on the ring's surface. The subtle gravitational effects caused by the moon shaped the material of the ring. The small moons, including Pan, orbit within the rings and appear to sweep their paths clear. The moon Mimas draws particles from the ring, creating the vast Cassini gap. The other rings are shaped by small moons, such as Romethos and Pandora's bow imprinted on a lake. Doni's leapt up and down like a mischievous foal, using gravity to draw dust particles into towering sand dunes up to 3 kilometers high. It plowed through a 35 kilometers wide area on the battlefield, known as the Killer Division. The larger moon Pandora has created the 325 kilometer long Onket gap in the A ring, causing ripples along the ring's edge. Its gravitational pull also generates a swirling stream of dust particles. Based on this gap, researchers since the late 19th century had predicted the existence of Pandora, long before it was actually observed for the first time. S striking shape differs from what people imagined, and at ISN. The moon atlas is slightly larger and has a similar structure, both composed of icy crystals with their own gravitational pull. Some small satellites orbiting Selene frequently dart through the F ring, creating water jets that shoot upward as evidence of their passage. The other small moons are too tiny to be observed, but they create petal-shaped resonance waves in the icy rings surrounding Saturn. The growing complexity of these rings moves like a silent melody playing out. Every 14 years, Saturn's ring plane aligns edge-on with the Sun when viewed from Earth. Sydney was fortunate to witness this fascinating astronomical phenomenon at precisely that moment. Essentially, the sunlight reaching the rings has been blocked, so they don't cast shadows on Saturn. They can only be seen by the light of Saturn reflecting off them and cast no shadow on the planet. They can only be seen thanks to the light reflected off them from Saturn. Here, the image has been digitally enhanced multiple times. Only the slightly tilted ring compared to the others can receive sunlight. However, because the rings are so thin, any tall structures within them would cast shadows onto the flat surface of the rings. At the outermost edge of the B ring, something unexpected suddenly appeared. Hundreds of elongated figures stood towering like a field covered in icy thorns. According to geometric principles, these points must reach a maximum height of 1 kilometer. Like icebergs adrift in the vast, nearly empty ocean of space. These spiky shapes may be sculpted by the invisible hand of gravity resonating with one of the lunar flows. Perhaps they were pulled out by the electrostatic force generated by Saturn's magnetic field. Some of Saturn's rings constantly change shape, while others remain stable for many years. How long have these shimmering icy rings existed? They may have formed within the last 100 million years. When the lunar circuits freeze or the star chains collide, or are violently pulled by Saturn's gravitational force. Or they could be as old as Saturn, remnants left over from the early days of the solar system's formation. Cassini probably hasn't found the exact answer yet. North Pole, the Cassini spacecraft captured a striking image of the planet. The flow is bent into a hexagonal shape due to the resonance of wind energy. It appears that a shallow jet stream is moving eastward, occasionally hindered by storms. The reaction proceeds by converting into the most stable geometric form with 6 sides. This polar monsoon region has a diameter of approximately 32,000 kilometers. You could fit 2.5 Earths in there. The wind here blows even faster as it nears the pole, reaching speeds of up to 540 kilometers per hour. Why did the Cassini spacecraft burn up into a fireball when entering the atmosphere? The international scientific community has unanimously agreed to avoid any risk of contaminating Saturn's moons. Especially the 2 moons Enceladus and Titan. Inside, the Cassini spacecraft maintained a warm temperature, nearly equivalent to typical room temperature. Any bacteria that enter during assembly can survive quite easily. Cassini's radioisotope thermoelectric generator will remain hot for decades to come. If the spacecraft were to accidentally collide with Enceladus, Cassini could easily penetrate the ice layer and melt into the hidden ocean beneath. In 2009, studies revealed that the Cassini spacecraft still had enough fuel to travel beyond Saturn's orbit. To explore the giant ice planets beyond Uranus or Neptune, the ship was likely sent back from Jupiter. You can also venture into space to explore the comet-shaped asteroid cluster named Centros. But to gather all possible scientific knowledge from the Saturn system, Cassini's journey will come to an end here. This made the trajectory design engineers at NASA's Jet Propulsion Laboratory, JPL, rethink their approach. Develop a micro-model of orbital dynamics for the SOST mission. This plan optimizes continuous flights across Titan's orbit is designed at an optimal altitude to observe the poles and the Earth. The long flight orbits help map the planet's magnetic field. The flat equatorial orbit is used for observing and studying moons, and ends at the summer solstice in the northern hemisphere, corresponding to when the Cassini spacecraft arrived in the southern hemisphere during its summer. Between these 2 events, scientists can observe the complete seasonal cycle on Saturn. Scientific research based on data from the Cassini spacecraft will continue for decades to come. Just an 8 meters per second boost to Cassini's speed would be enough to send it spiraling into destruction. The final flight, at 100,000 kilometers from Titan, quietly concluded Cassini's journey. The ship will continuously dive deep among the debris within the asteroid belt and its turbulent atmosphere. These maneuvers are too dangerous to consider when designing the Cassini spacecraft. Transmitting Earth's scientific data continuously until the final moments. At 2 p.m. on September 15, 2017, Pacific Time. The research team at NASA's Jet Propulsion Laboratory, JPL, in California conducted the monitoring. Cassini plunged into Saturn's atmosphere and vanished forever.